Hey everybody, time for the second video for Unit 5. And in this video, we already know a little bit about classes. We already know a little bit about object orientation. What we're going to do is we're going to take a new class, completely new. So you have your dice, you have your student record, you have your checking account from last video. Now this video we're going to do something completely new. So you have just a fourth example. We're going to run something real quick with it. And then we're going to talk about two things that come along for the ride when we do object orientation. We're going to talk about inheritance. We're going to talk about polymorphism. But first, let's take a look at the code. I have it right here. And I just created a simple class called animal. And basically what we're going to do is we're going to run it. So I guess I'll just call this I'll call it my animal. And I will assign it to the animal class. And what does the animal class ask for? It asks for a name and a weight. So I will say Bob, and Bob's weight will be 40 pounds. Okay, so then I'm going to print, and I have getters and setters. I sure do. I'll print get name. And hey, you think it would help if we put the variable in front? MyAnimal.getName and MyAnimal.getWeight. Alright, so we're going to print that out, and if the gods are with us, let's run this, and then we're going to trace through the code. And we got a boo-boo already. What did I do wrong? My animal is not defined. What did I call it? Oh, I did it lowercase. Mr. Hungarian notation, getting bit in the rear end by not remembering it. So now when we run things, we should be fine. I get Bob and I get 40. Let's get in a little area here where we can run things and talk about them. And of course, like last time, we are going to go off the screen with this one, trust me. But right now we don't have to. Okay, so we got Bob and 40. Let's trace through this code and figure out what we have here. So we look at the beginning of the code and there's comments, so we ignore them. Class, animal, we load it into memory as if it's a function, okay? So we're not really considering it right now. It's a class called animal. It has a constructor. It has getters and setters for both of the variables, the instance variables that it has, name and weight, and it has a single method down here called speak. And when you run speak, it prints the word sound. We're going to figure out what that's about a little bit later. So then we have a comment. Like last time, the first thing we really run is the second to the last command. And I grab a variable called myAnimal, and I assign it an object created with the animal class, and my two arguments here are the string Bob and the integer 40. So what happens here? We are going to assign this an object created with the class animal. Is there a class animal? Yes, there is. So let's run the constructor. Init dunder, self, which is a memory location that points to the object itself, in this case the myAnimal object memory location. Name is going to be the string Bob, and weight is going to be 40. So what do? I set up two instance variables, and I save those two data points. So I have Bob as a string and the integer 40 in weight, and then that's done. It's completely done. It doesn't print anything, it doesn't do anything, so you don't see anything here, but the object has been created and it's there to be used. We know that because the very next line we do a print statement, and I do the getters for two different instance variables. First thing I do is myAnimal. What is myAnimal? MyAnimal is a variable that holds an object created with the animal class. Does it have a method called getName? Well, I go to animal. First one, getName. It does. What do I return? Self.name. Well, I set that when I ran the constructor. So name in this case is Bob. So the first thing I'm going to print is Bob. That's why we see it there. Same thing with getWeight. MyAnimal. Created an object created with the animal class. I go to the animal class. Do I have a method called getWeight? I do. So I return self.weight, which was set to 40 when the object was created. So right here I return Bob, and then I return 40. Okay? Here we have a pretty straightforward class constructor, getters and setters for the two instance variables, and then one simple method called speak that we're going to talk about in a little bit. Okay? We're set. We're up to date. We're back where we were at the end of the last videos. We're hip to classes. We're hip to objects. We know about methods. We know about constructors. We know about instance variables. We're in pretty good shape here. Now, what if I wanted to create an object that was a cat? This is a generic animal, regular animal. I want a cat. I want something specific. The question becomes, do I have to create a whole brand new class in order to get my cat? The answer is yes, but there's some shortcuts we can take. So the first thing I'm going to do, and I'm going to, first of all, we're not going to need this, so I'm going to Zotz this code out. And then we're going to come underneath here, and I am going to say class cat, okay? But now, a little inside baseball. Last video, you saw when I did the class checking, there were no parentheses there. I just went with the colon. If you're going to leave it blank, it doesn't really matter. But you can, the colon, the parentheses, you can have the empty parentheses there. Because what you're going to learn is that you use those parentheses if you inherit from another class. Let's say I want to create a cat. And what I want that cat to do is I want to have the cat's name, the cat's weight, and the cat's color. Okay, I'm going to add color to the mix. I already have a class that does weight, that does name, that has a speak method. I mean, what if I don't want to type all that code in over again? I don't have to, because what I can do is I can inherit from the animal class all of its functionality. Okay, and the way I do that is I type the class in right here when I create the class. Okay, so I say class cat, but I inherit from animal. Okay, but this isn't cost free. What's going to happen now is I have a cat class. So the first thing I need to do is do my constructor. So I do init, and what am I going to do? I'm going to do self, I'm going to do name, I'm going to do weight, and then like I said, I'm going to add color. And that's going to be my constructor for my cat. But now I've got to pay the freight. Because I am inheriting from animal, I've got to go and run animal's constructor. Okay? It's almost like, and I always likened this to Mr. Potato Head, it's almost like you've got to go get that base spud with the base functionality that you have, and then if you want to add things to it, you can add things to it. So when we inherit, we have to run the constructor of the class we inherit from, which is sometimes called the superclass or the class above you. So how do I do that? Well, I know what class I'm going to, so I can refer to it explicitly. I can say animal, dunders, okay, underscore, underscore, init, dunder, dunder, and then, and this is the only time you're really going to do it, give it self, because you want to give it the memory address of cat, because at the end of the day, this is all one big cat object. Okay, so give it self, give it name, and give it weight. All right, if you look up here, that's all that animal needs. Color we're going to have to handle on our own. So you run the animal constructor, and what it's going to do is kind of create an object of an animal object for you to use. And then what do? We handle color on our own, because that's the added functionality that we're adding with cat. Okay. So we've run the constructor for cat, we jump up, we run the constructor for animal with self, name, and weight, and then we add the color at the end, because that's the extra thing that we're adding, okay? Now, because we did color the way we did, we need to do getters and setters. So I will say get color, and I didn't do a colon, so I didn't get my indentation, and that will return self.color. And then in this case, we're going to do a setter. So we'll say set color, and that will take 2 because it will take color. And then self.color will be assigned the new one that we sent in. So right off the bat, we've got getters and setters, and we're in good shape as far as that's concerned. Now, the one last thing we're going to do, and we're going to get to it in a second, is we're going to redefine speak. Okay? Speak is, Popo's getting somebody. Self, we're going to print meow, and we're going to get to that in a second. Okay? So now I have a class called cat, which inherits from animal, but adds the functionality of a color and changes the speak method so that instead of sound, it says meow. Okay? Now, we're going to run this, and then we're going to trace through it, and we're going to talk about how the inheritance worked and what it got us. Let's go grab a variable, call it cat1, and we're going to create it with the cat class, and I am going to name my cat Felix. Felix is going to be a 50-pound cat. Got a lot of those at Rutgers. And the color is going to be, what was Felix the cat? Felix the cat was black. Not very lucky. So we do that. Then I'm going to print. What am I going to print? I'm going to print cat1 dot get color. So I'll print the color out first, and then I'll say cat1 dot get name. So we get the cat's name. Okay, so let's run this. Any typos? Yes, of course there is. No attribute get color because I need it capital. Yes, yes, yes. So I did it here in the call. All right, Black and Felix. Now we're in business. Let me shrink this up and get an area where we can get together and talk a little bit. We don't talk enough. All right. All right, let's trace through the code. I've got comments, don't worry about it. Class animal, stick it in memory. Class cat, stick it in memory. Again, the first thing we look at here is cat1. Cat1 is a variable. I've probably got coffee all over my face. I can't feel anything on this dopey beard. Cat1 is a variable, and we have assigned it an object that was created with the cat class. So do we have a cat class? We do. We send it Felix, string, 50 for an integer, and the string black. So when we send it up here, cat animal, we run the constructor. Init self, which is the memory location of the thing. Remember, don't worry about self. Name is Felix, weight is 50, color is black. So what's the next thing we do? We run the constructor of the animal class. So we come up here. Is there an animal class? There is. So we run its constructor. Self, name is Felix, weight is 50, and we set these instance variables right here. We're done with that constructor, so we come back here, but the call ends right here, so now we define self.color, which is black. Color came in black, so we set that instance variable to black. And then we return control back here. That's it. Nothing was printed. We just created an object in memory in the background with those instance variables. So now, the second thing we're going to do is we say print, and then what? Cat1 get color. So this is the simple one. Cat1 is what? It is an object created with the cat class. Do we have a cat class? We do. It's right here. So I'm looking for a method called get color. Does it exist? It does. What do we return? The variable self.color, which was black. So the first thing we print is black. All right? Easy peasy lemon squeezy. Now, the second thing we want to do is cat1.getName. Okay? So I say cat1 is what? It is a variable that holds an object that was created with the cat class. So, is there a method called getName? No, there isn't. So Python's about to throw an error, but it asks one more question. It says, did we inherit from anything? And if you come up here and look, it says, yes, you inherited from animal. So now we go to animal. Animal says, do you have, well, the code says to animal, do you have a method called getName? And we come down here and it does. So return self.name. What is the name? In this case, this variable was given the value Felix. So we print Felix, and that's what prints right there. Okay? So if we wanted to, we could add all kinds of extra functionality. It's just we don't have to go back and redo the name and redo the weight because we already have it written. We can inherit from cat, and when you run something, it comes up here and looks for it in cat, and if it doesn't find it, it goes back to the top and then it looks for it in animal. This is basically the concept of inheritance, and what it really does and what it's really for is something that we want to promote when we talk about object orientation. What it's about is code reuse. We don't want programmers and coders having to waste their time and reinvent the wheel every time they sit down to write a program. You want to be smart and design your program so that if you have a framework or something that you're going to use a lot, you write it once and then you use it. And what I always say when I teach this class is that I would be negligent if I sent you out into the real world without a little bit of knowledge about object orientation. Because you're going to see when you get out there and you start using Python for projects and you start doing things, it's all object orientation. What you're going to do two things. You are going to have classes in your libraries, not so many functions anymore, and you're going to instantiate those classes and run the methods on them, okay? You're going to give it some data, and that's going to be the instance variable, and then you're going to be able to run a whole bunch of methods on it. The second thing you're going to be able to do, and this will happen a lot as well, when you're coding, you can inherit from classes that are in the third-party libraries that you can use. So you're going to inherit all this functionality, and you're going to learn how to use it. The APIs are online for the different things you want to use. And all of a sudden now, you can just inherit the code from classes that you get from libraries. If you want to add a little bit to it, you can add a little bit to it. The whole idea is that, let's say I have a car. Okay, what's basic about cars? Cars have four wheels. Cars have engines. Cars have axles down the middle. Cars have seats and steering wheels. Cars have a lot of basic stuff that are the same with every car. But then let's say I want to create a Ferrari. Okay? Some things about that car are a little bit different than other cars, price being one of them. And you can give it make it red, and you can inherit from the car class and then add all the extras. When I want to make a Volkswagen, I can inherit from the car class, and then I can make my special trunk, and I can put the engine in the back and not the front, and I can do all of that crazy stuff. Okay? My Jeep, same thing. I inherit from car, and I make all the changes I need to make to customize my thing. So now I've got three objects, a Jeep, a Ferrari, and a Volkswagen, and they all inherited from car. But they're all different because I'm the programmer, and I created my different objects that way. I didn't have to rewrite the wheel code. I didn't have to rewrite the engine code. Well, I may have for the Ferrari. I didn't have to redo the steering wheel, the fact that there's a seat, the fact that there's doors, the basic stuff. I was able to reuse that code, and that's the key with inheritance. It's code reuse. In this case, I'm thinking ahead, and I'm building a system. I know I'm going to have animals. So what do animals have? Animals have a name. Animals have a weight. So I want to do the basics. You notice I didn't put legs there. Some walk on 4 legs, some walk on 2 legs, blah, blah, blah. So things that are going to be general are the kinds of things you would implement in what's called a base class. Some classes, now that I've said the term base class, some classes are never meant to be instantiated. They're meant to be inherited. They're meant to give you that base functionality, and then you inherit them. And you run, you instantiate your class that you created. That's what you want to do. You'll see, and we're going to talk about it in a second, some methods don't even have anything in them. Some methods are just there to remind you, hey, you better write this. Okay? Kinds of leads us kind of naturally into the next point. We've talked about inheritance, where you're inheriting the capabilities of a bigger class to use in your new class. But we also want to talk about something called polymorphism. Polymorphism sounds complicated. It's really not. If you think about the etymology of the word, poly, many, morphism, morph not as in change, morph as in form. So it means many forms, okay? Look at the animal class. You see that speak method right there? It says speak, and if we ran it, it would print sound. Well, here in cat, I wrote one called speak as well, okay? You notice all of these methods have different names. Get color, set, wait, but these two have the same name. That's the key to polymorphism. We'll get there in a second. So I said for the speak method for my cat, I'm going to write print meow. So what am I going to do here? I can go cat1 dot speak. And when I run this code, it's going to say meow. But let's, for 2 seconds, pretend that's not the case. And that I don't have that method. Well, now when I rerun it, it says sound. Because what happened? I came here, I said cat1.speak. So cat1 is what? It is a variable that holds an object that was created with a cat class. So I come up to the cat class and I say, is there a method called speak? Well, there's not now because I commented it out. So Python is about to throw an error, and then it says, wait a minute, did we inherit from something? Yeah, we did. Animal. Come up to animal. Do we have a speak method? We do. What does it say? Print sound. Now, you might be saying to yourself, well, that's not a big deal. We just went through that. That's what inheritance does. It looks for it in the class you just created, and if it doesn't find it, it looks for it in the inherited class. But there's a difference here. The difference is that those two methods have the same name. Okay? So what I did here for the cat class is I did what's called overriding the base class. What you'll see a lot in a base class, I made this say print sound because I didn't want to freak you out. But a lot of times what you'll see is the keyword pass. Just a placeholder. Okay? Just a placeholder. It does nothing. So now we'll run and we'll hit that pass. So now if I run things and it gets up there, just nothing happens because pass did. Now if I didn't have the pass in there and I ran it, it would blow up. Python doesn't like it. Python wants to see something after that colon. So now it's throwing an error. The minute I put that pass back in there, all of a sudden everything's better and everything's good in Dogpatch. But nothing's running. When you have an abstract class and you see a pass in the middle of a method, it means that it's not meant to be run. That you are meant to override it. And make sure that when you inherit from this base class, that you're implementing that you have that method in yours. And indeed, we will, because our cat says meow. The point being this: if I use animal and I create a dog, which we're going to next video, then I'm going to rewrite speak and have him say woof. If I have a cow, I'm going to have him say moo. I'm going to have a pig, I'm going to have him say oink. Horse, I'm going to have her say whinny or whatever. The horse says bray, I don't know. So I could have an array or a list full of animals. I could stick them in a loop and I could just say one command, speak, because it's the same name for all of them. But they do different things based on the context, based on what they are. Cats are meow, so I wrote the speak to say meow. Dogs are dogs, so the speak says woof. Okay? Many forms. That's where it comes from, polymorphism. So I want this capability or I want this behavior for my class, but depending on what the specific thing is, it's going to act a little bit differently, but I use the same name. Okay? Now, I don't want to get in the woods on this, and maybe in the next video we'll even talk a little bit about it. But there's a difference between what's called overriding and something called overloading. Okay? If you're a C++ or a Java person, you may have heard the term overloading. Python doesn't support overloading. We do other things to get around it. We're probably going to talk about that in the next video when we do OOP goodies. You will probably or may, through your travels, heard of something called operator overloading. Remember when the plus, it means addition with numbers, but it means concatenation with strings. That's something called operator overloading. Give the same operator different jobs depending on the context, depending on the operands that it's working with. That's a completely different animal. What we do to implement polymorphism is we override the base class by basically cutting in front of it in line. By basically saying, okay, this is going to go to cat and look for a speak. I'll give it one. Okay, so that way it'll run my speak and it will say meow every time. Okay, that's the idea of polymorphism. Many forms. All of the different animals in this crazy zoo we're making are all going to have a speak method and they're all going to say different things because we gave them that specific behavior. Okay, when we talk about object orientation, we're talking about inheritance because we're talking about code reuse. And we're talking about polymorphism because then our specific things can have the same behavior, in this case speaking, but they're not going to speak the same thing. So based on context, we can tweak the behavior a little bit. At the end of the day, the base is the same thing. We want it to make a sound, but that sound's going to be different depending on the context. We can do that with polymorphism, okay? All right. Absorb all this. I am not going to put this code on Canvas yet, because what's going to happen is there's going to be yet a third video. And in that third video, we're going to talk about class variables, where our objects can talk to each other. And we're going to talk about deconstructors, which are kind of the opposite of constructors. And we're going to talk about overriding a string method so that when you print the variable, like we printed the Lars account from the checking video, you're actually going to get something, whatever you want to show the user. You can print. You can control what happens when somebody runs a print on your object. Then we're going to wrap it all up by bringing in some compartmentalization and modularity. We're going to throw all these classes in a library. We're going to import from that library, and we're going to run all of our animal code out of a library so that we're modular. And you start seeing that. Because at first, when you learn about libraries, when you did Unit 3, you learn how to put functions aside and then go get those functions and run those functions. In the real world, it's mostly classes now. Libraries are full of classes that you're going to instantiate and run the methods on those classes. You've been doing it all along. Think about what a list is. You've been running, whatever your list name is, .append. What is that? When you ask for a list, you instantiate a list object and you run the append method on it. With strings, when you did upper or lower or split or replace. What are those? Those are methods on a string object. When you were using type, the first week of the class, when you were using type, you said type number and it came back. What did it say? It said class int. It said class float. Because at the end of the day, those are objects too. Everything's an object at the end of the day. All right? All right, I don't want to get too far ahead. Patience. In a couple days, we'll get that third video, and then all of this code will be up on Canvas for you to take and play around with and do things with. I often tell people, Unit 5, I try to front load the resources because I want you to have as much time as possible to work with the assignments, okay? But I don't want you to just quick run through it. I want you to take your time. I want you to steep in it. I want you to watch it a few times. I want you to run this code because that's how you learn, and then you can play with it, and then you can do a bunch of different stuff, all right? All right, so we're good. Wait a couple days for that third video, and you have a good night. I'll talk to you later.